Well, I've got a really boring presentation title, but I promise this is going to be interesting. My name's Tom Hildebrand. I'm from Ubiquity. It's our second year here. Excited to be back. I just put all my details up there. There's my email. I'm on the WLPC Slack. You can find me on LinkedIn. Some of you might have my phone number. Go ahead and bother me. I don't care. I want to talk today about airtime utilization and specifically some of the mitigations that you can do that aren't just the typical software things. So we all know about airtime consumption, right? We all know how dangerous it is in a public network. It's exceedingly common and hard to diagnose. Part of my role at Ubiquity is sometimes I get the tough wireless cases, the ones that our normal support guys can't quite figure out. And when you see a case that comes in and somebody says, oh, my Wi-Fi is slow, my phone won't connect, is your first guess really going to be airtime, or are you going to start looking at things like, is their device just out of date? Did they just put in the wrong password? It's hard to get to this conclusion first. Clients are just getting chattier and more numerous, too. I have maybe 50 devices on my home network, and I had 2 full pages of MDNS services. My dishwasher has its own MDNS service. Now, you might ask why I connected it to Wi-Fi in the first place. That's on me. But once you start adding in protocols like multicast AV, multiple users, there goes your wireless neighborhood. The channel's cooked. But then you say, okay, I've got a corporate network, I got an office. I'll just turn off MDNS, I'll turn off multicast, I'll just make the air as clean as I can. But I'm starting to have people push back on me about this. Like, I want to set up Chromecasts or Apple TVs in my conference room so people can just cast and connect. I want to advertise printers with AirPrint so people can print from their phones. You can't just turn those services off completely anymore. Or some people don't want to give up the convenience for it. So there are, of course, mitigations that we all know about, but they come at a cost. Put earmuffs on the APs. Set a minimum client RSSI. That way they can't connect below a certain dBm. Treat everything below an even lower dBm as noise. That's fine. But then you start getting into having to do surveys and tune power, and even then, this is really just correcting for bad clients. We can crank up the data rates. That works a lot in public venues. But that kills your legacy and your IoT connectivity. Again, not suitable for every environment. Needs specific testing. We can do this multicast to unicast conversion. A lot of vendors, a lot of people here leave that on by default. And that works for your higher performance 5, 6 gigahertz networks. But on 2.4, be careful. We had an IoT case where somebody had a ton of chatty 2.4 gig stuff. And we turned on multicast unicast conversion. Once we did that, suddenly, because it's all unicast traffic now, the TX retries went through the roof. Then suddenly we were eating up even more airtime than if we had just left the multicast alone. Now, of course, you might say, well, just get rid of all your 2.4 gigahertz clients, but again, you can't tell that to just every customer. Now, Wi-Fi Alliance, to their credit, they've tried a lot of mitigations in software, a lot of things through the new standards, BSS coloring, restricted target wait time in Wi-Fi 7. But again, right client mix. All it gets back to, if a customer has specific legacy devices, critical devices that don't speak these, what's the point? So that's where we come into the limits of software, right? We're bound by the limitations of clients that want to connect. So what do we do if we just have a hostile RF environment, right? Forget the clients that we're bringing in. What about everything around us? We've got this crappy Hilton Honors network that's screaming on channel 44 right now. The co-channel interference, the adjacent channel interference, unavoidable sometimes. And to get those high MCS rates, high data rates, you need a high SNR. But what do you do in a noisy environment? You can't defeat physics with software. But you can get a pretty good fight going with hardware. So at Ubiquity, we've leveraged a lot of our fixed wireless experience. Some of you may have experience with our AirMax products, our point-to-point stuff. We've taken our Prism filtering and brought it to some of our new enterprise APs. Campus over here, and audience over here. So what does Prism filtering actually do? This is a really pretty diagram that our marketing people did, so I'll do my best to explain it. Instead of just connecting the antenna directly to the receiver on the radio, How it works is the AP will choose a chunk of spectrum around your target channel. So isolate it, then brick wall filtering on either side. Chops off the high and the low. Make sure it's deaf to absolutely everything but your clients. Then we amplify that back up. This is a patented technique that we've been using very successfully in the point-to-point world, but now there's tremendous application to do it in the Wi-Fi space, especially in high-density deployments, directional deployments, outdoor deployments. So this is a pretty typical 5 gigahertz waterfall chart for a Wi-Fi 7 client. We got these out of the lab just this week, just doing an iPerf test. Nice and simple. But let's say you add an adjacent channel interferer. You're doing an outdoor deployment. You got a couple of those E7 campuses blasting in 2 different directions. You've got a high power co-channel interferer right here, or adjacent channel interferer. Your waterfall drops. But with the prism filtering on both of those APs, look at the performance gains that we have. At these critical levels, minus 50, minus 60 dB, you're getting about a 50%, 60% throughput improvement. And then especially at the fringe levels, minus 70, minus 80, when a client might be holding on to an AP to finish a call or finish sending something out, finishing those iCloud photo backups that everybody loves on their public Wi-Fi, you're getting a 226% performance improvement, and you're holding on to those higher MCS rates for longer. So really, what are our lessons here? We all know this. Keeping airtime, controlling airtime use, keeps the clients talking faster for longer, keeps the performance up, keeps the network decongested. But you have to balance between that user experience, all the convenience things, being able to cast to the TVs instead of having to get a cable like we have here. Keeping that airtime clear is key. There are plenty of software features, plenty of beacon changes, plenty of everything that we can do, but those have huge trade-offs for the end users. Hardware antenna design, though, filtering, the nitty-gritty stuff, the black magic of the Wi-Fi world, that helps you with the things you can't control. In the end, you control the clients on your network. You can block certain things, you can set data rates, you can do whatever you want. But everything you can't control, that's where filtering comes in. And that's where you get into the really fun parts of controlling airtime and controlling frequency use. So, just to leave you guys with one more thing, we're going to be raffling off license-free Wi-Fi 7 APs and a full stack of unified gear, a switch, AP, gateway for the rest of WLPC. And we're also going to be around for the Wi-Fi 7 Fest tonight if you'd like to learn more about these APs that have been serving you guys Passpoint these last couple of days. So that's all I got. Again, thank you guys.